Welcome to our first tutorial. We are going to be solving STEM mathematics on this channel. Just make sure if you're visiting this channel for the first time, hit the subscribe button and the notification so that you don't miss any videos that we're going to be posting on this channel. So today we're going to start with how to find the Eigen values and Eigen vectors. So now we are going just to find the Eigen values and Eigen vectors of a 2 by 2 matrix. So I've actually put the steps that you're supposed to follow, and I call it the process. To solve the Eigen values, the scalar and the corresponding Eigen vector of n by n matrix of A, you'll have to follow step by step. And step number 1, you multiply an n by n identity matrix by a scalar lambda. Step number 2, subtract the identity matrix multiple from matrix A. Step number 3, find the determinant of the matrix. Find the determinant of the matrix. Step 4, solve for the values of lambda that satisfies the equation of the determinant, where determinant of A minus the scalar multiplied by the identity should give you a 0 matrix, a 0 vector. So now we're going to have a question 1. We come here now, we're saying find the Eigen values and Eigen vectors of matrix A. We'll have in the column we have 7 and 3. In the second column we have 3 and -1. So now let's follow the steps that we just outlined. We said the first step, you have to multiply the identity by the scalar. So step 1, we are multiplying this identity by the scalar. So we know that the identity of a 2 by 2 matrix is just in column 1, 0, and the second column 0, 1. So if you multiply the scalar and the identity, you are going to get the lambda and 0, 0, lambda. So now we said the second step, you'll have to subtract the identity matrix from the identity matrix multiple from the matrix A. So this is what we have here. Our A is just the original matrix that we're given in the question. So you write it like that, then you subtract with what you got in step 1. Then you're going to have 7 minus lambda in the column 3, and the second column is 3 minus 1 minus lambda. Then you go to step 3. We said you'll have to find the determinant of a matrix. So how do we find the determinant of the matrix that we found in step 2? So now you multiply the major diagonal, then you subtract and multiply the minor diagonal, and we're going to have this equation here, which is just giving us the what? The quadratic equation. So solving the quadratic equation, we're going to have lambda squared minus 6x minus 4. So you have to find the product sum factor for you to find the factors. You can see that we have lambda -8 and lambda plus 2 is equals to 0. So you get the lambda minus 8, you equate to 0, and you're going to get lambda and 8. And the second one, you just say lambda plus 2 is equals to 0, you're going to have lambda minus 2 is equals to -2. So therefore the Eigen values are lambda 1 is equals to 8 and the lambda 2 is equals to -2. So now in the next video we'll have to see how we can find the Eigen vectors. So make sure you hit the subscribe button and the notification bell so that you don't miss any video that we're going to post on this channel. Thank you for watching.